Ever wondered how Hadoop, that powerful open-source software framework, manages to execute tasks so efficiently? You know, the one that's become a household name in the world of big data, the one that's practically synonymous with handling vast and complex data sets. It's almost like it has its own magic formula, right? But what if I told you it's not magic, it's just good old-fashioned computer science? Well, let's delve into the world of Hadoop and unravel the mystery together. Grasping Hadoop's task execution requires understanding its basic components. So, let's break it down. Hadoop's heart beats with two main components: HDFS, or Hadoop Distributed File System, and MapReduce. HDFS is like the nervous system of Hadoop, storing vast amounts of data across multiple machines. It's designed to provide high-speed access to this data, ensuring that the information you need is always at your fingertips, no matter how big or complex the data set is. On the other side, we have MapReduce. If HDFS is the nervous system, then MapReduce is the brain, processing the data stored in HDFS. It takes a big task, breaks it down into smaller pieces, and then combines the results to form the output. This divide and conquer method makes it possible to process huge data sets quickly and efficiently. Now that we have a basic understanding of Hadoop's components, let's explore how tasks get executed. Task execution in Hadoop is a beautifully orchestrated process. Think of it as a maestro conducting a symphony, where each instrument plays its part at precisely the right time to create a harmonious melody. Our first movement begins with job submission. A user submits a job to the Hadoop framework, which is essentially a program written in a language like Java or Python. This job is a set of instructions that need to be executed on a large dataset. Next, our symphony moves into the second movement, splitting the job into tasks. Just as a composer breaks down a symphony into smaller parts, Hadoop breaks down the job into smaller tasks. Each task is a smaller, manageable piece of the job that can be worked on independently. This is the heart of Hadoop's parallel processing capability, which allows it to handle vast amounts of data with ease. Now, we move on to the third movement, task assignment. Like a conductor assigning parts to each instrument, the Hadoop framework assigns each task to a node in the cluster. Each node is a server that is part of the Hadoop setup. The job tracker, a service within Hadoop, is responsible for this task assignment. It takes into consideration the data locality and the current load on each node while assigning tasks. With tasks assigned, we move into the fourth movement, execution. Each node executes its assigned task, processing the data stored on it. The nodes work in parallel, each playing its part in the grand symphony. This is where the magic happens, and the power of Hadoop's distributed processing comes to life. Finally, we reach the fifth and final movement, the collection of results. Once all tasks are completed, the results are gathered and consolidated. The job tracker oversees this process, ensuring that all the results are collected and the final output is produced. And voila! That's how Hadoop executes a task from start to finish. A symphony of data processing, perfectly orchestrated. Each step, from job submission to result collection, is a vital part of the process, working together to create a masterpiece of big data processing. Let's recap the fascinating process of task execution in Hadoop. It's a journey that starts with accepting a job, followed by the splitting of data into manageable chunks. These chunks are then distributed across the Hadoop Distributed File System, or HDFS, making the most of its robust and reliable storage capabilities. Next, we step into the world of MapReduce, the heart of Hadoop's computational prowess. The map phase takes these distributed data chunks and applies a specific function to them, generating a set of intermediate key-value pairs. Then comes the shuffle and sort phase, where these pairs are sorted and sent to the right reduced tasks. These tasks combine the values associated with each unique key, producing a consolidated output. The entire process is overseen by a resource manager and node managers, ensuring smooth operation and efficient resource allocation. But what's the big deal about all this? Why do we care about the steps involved in task execution in Hadoop? Well, this method allows for fault tolerance, scalability, and speed, making it an ideal choice for processing large data sets. By distributing data and computation across multiple nodes, Hadoop avoids the bottleneck of a single point of failure. If one node fails, the task is automatically rerouted to another, ensuring your data processing doesn't miss a beat. So, the next time you marvel at Hadoop's efficiency, remember the intricate process behind task execution.